Nathan Putch. I'm currently in the 7th grade and I go to St. John the Evangelist School. This is rocket science. I became interested in this project when I was in 5th grade and we studied space exploration. And the purpose of this project was to explore how various amounts of thrust affect the flight of the rocket. And some important information I gathered was that a rocket is subjected to 4 forces. They are thrust, weight, lift, and drag. Thrust is a positive force, which is created by the engine that propels the rocket into the air. Weight is a negative force, which is created by Earth's gravitational pull. And lift and drag are the aerodynamic forces, and they're slightly negative. Lift is created by the fins on the rocket, and drag is created by the surface area. And I also learned about Newton's 3 laws of motion. The first law states that every object will stay at rest until force is applied, and that every object will stay in motion until force acts on it. This explains why a rocket stays still until the engine fires off.
I like color here.
The second law states 3 things. Firstly, it states that a object will go in the same direction that the force is applied. Secondly, it states that an object with twice the amount of force will have twice the amount of acceleration. And finally, it states that a object with twice the amount of mass will only have half the amount of acceleration. And this explains why a rocket will stay still until the engine's force can overcome the force of gravity. And if the rocket has more thrust, the rocket will go greater in altitude. And if the rocket has more mass, it will need more thrust to accelerate it. And the third law states that every reaction has an equal and opposite reaction. And this explains the generation of thrust. The thrust pushes down towards the ground, while the reaction force pushes it up, the rocket up. I also learned the 6 main parts of the rocket. They are the nose cone, which reduces air friction, the tube that holds the engine, the fins, which guide the rocket, the engine, which propels it into the air, and the parachute for recovery. I also learned the 4 main stages. They are the thrust stage, the coast stage, the ejection stage, and finally the recovery stage. It was hypothesized that the Alpha 3 rocket, which is the least in mass, with the C engine, which has the greatest amount of thrust, will go the greatest in altitude. And for this experiment, I shot up 2 rockets with different masses, and then used a right triangle to obtain the altitude. And the procedure I used was predict the altitude, use the altitude tracker to predict the altitude, prepare the rocket to be launched, use the altitude tracker to determine the altitude, then repeat the steps with the B and C engine, and then repeat the steps with the second rocket. The materials I used were the Big Bertha rocket, the Alpha 3, the altitude tracker, 2 A engines, 2 B engines, and 2 C engines, a launch pad, safety goggles, a launch controller, glue, igniters, 2 parachutes, wadding, a razor blade, a tape measure, and to analyze my data, I first made a data table and then made 3 graphs. And this graph is the force of the rocket engines. and it is measured in newtons. And for each set of engines, the amount of newtons that the rocket has, it doubles. And here is the mass of the rockets. The black cylinder is the Big Bertha, and the orange cylinder is the Alpha 3. And as you can see, the Alpha 3, it has about half the amount of mass. And here is the observed and the predicted altitudes. But before I go into that, I'd like to explain how I got those. For the predicted altitude, I used a computer simulation, where I had to enter the thrust and the mass, and then it used this formula. And for the observed altitude, I used the altitude tracker, where I had to look up through the tube, and then they got an angle with this. And then I put that into a chart and multiplied that to get a tangent, and then multiplied that by the baseline, which is how far the measure is from the launch pad. And here is in the blue is the observed altitude, and in the red it's the predicted altitude. And here are the two rockets with the A engines, and the Alpha 3 went the greatest in altitude. And here is the rockets with the B engines, and once again the Alpha 3 went the greatest in altitude, and it went about as high as the St. Louis Arch. And here is the two rockets with the C engines, and once again the Alpha 3 went the greatest in altitude. It went about as high as the Sears Tower or the Willis Tower. And
Wow.
I found that a heavy rocket with little thrust will not go great in altitude. I found this from the test of the Big Bertha with the A engine. I also found that a light rocket with the greatest amount of thrust will go great, or with a great amount of thrust will go great in altitude. I found this from the Alpha 3 with the C engine. But the most important finding was that for each set of engines, the lightest rocket, the Alpha 3, went the greatest in altitude because it had half the mass. So and for each set of engines, the Alpha 3 went about double in altitude because it has half the mass. And this goes along with Newton's laws. And my results compared with my prior research. And for future studies, I would test a multi-stage engine versus a single-stage engine. And thank you for listening to my presentation. If you have any questions, I'd be glad to answer them.
Yeah.